I think I hit most of the main stuff. There's a few more things I could talk about droughts, but I think I got all the main stuff there, right? So the main issue here is variation, lack of rainfall, and we proceed through different types of droughts, right? As we have as drought grows, it tends to increase not just in intensity or severity, but also in geographic scope as well. And that's not necessarily the way most of our disasters go. Let's talk a little bit about what we're going to do for our activity today, if you haven't already worked on it and started on it. So basically, I have a couple different sources of data for what's going on. This is what we look like right now. So this is a fantastic product. So as I mentioned before, various actors that only want people to have information that pay for information, that have been actively trying to disassemble the National Weather Service for some time now, don't like this. But this is one of the ones that has sort of escaped. So I mentioned before, a lot of our national weather data products are specifically banned from having engaging interactive presentations, right? Interactive web graphics, etc. One of the exceptions is the folks that produce our drought-related data. So they have made fantastic strides, particularly in the last 15 years, to make products that are more easily consumable, usable, valuable to the consumer. I'd say droughts and hurricanes are by far our best publicly oriented data platforms from our friends that study the weather and the environment and stuff. And so this is a fantastic product. This is updated weekly. And so this is our National Drought Index. And so in our lab activity today, you guys are going to go to some of these different websites and sort of check them out and look at them. But this is done for the whole of the country, plus Alaska and Hawaii. But it's primarily, and I think Puerto Rico too, but it's concentrated on, or most of the effort is in the lower 48, because that's where most of the drought concern is. And so you can see the entire country, you can see the region of the country, and you can see it on a state level. In fact, you can drill down farther past there. So our friends that help us understand droughts, we have technically 5 different categories of drought. So one is no drought. That's what we all want to see. We all want to be in the no drought condition, meaning we're not experiencing any reduction in rainfall or precipitation that is causing us any impact at all. So there's no meteorological drought, there's no riverine drought, there's no soil drought, all that kind of stuff. And then we proceed through a series of stages of a little bit dry to 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 dry. And in this case, this is represented with growing hotness of the colors on the figure. So as we get darker red, maroon, we're getting more problematic. And so what we're seeing here are the counties of the U.S. because much of our response to drought is at the state and county level. And then major rivers are denoted with the blue. And then the rest is just the drought. And so this is updated. You can both see the current data and any of the historic data. You can compare one year to another. You can compare one region to another. There's all kinds of wonderful tools here. Also, because these are optimized to communicate to the public what's going on, most of the products have multiple ways you can you can collect the data. You can go up, if you guys have taken our GIS, Intro to GIS, you can actually get the geospatial data for this. You can get the raw data and put it in your own map. You can get this just like I just took a screenshot of this, so you get it just like that. Or you can get it without any of the legends. or you can get it without any text. And so that's designed to be as usable as possible for other consumers and other communicators of drought. So maybe you're a newspaper reporter and you want to put this in your article. Maybe you're a TV newscaster and you want to put this in, but you want to put your own text over it or whatever, right? So they provide it in many different forms, which is just great and wonderful and increases the utility and value of these data products. So this is where we are as of right now. And so again, the white or the blank or the clear area is in an area that's not experiencing drought. And again, this is also relative. So this is geospatially calculated as well as seasonally calculated, right? So we just experience rain. You and I just experience rain right now. But even last week we were having some rain. But if you have a look, Ventura County is still pretty orangey ready, right? And so that is both taking into account what's been going on in those specific areas right now, but it's also taking into account what time of year it is and how much rain should we have accumulated by this point in the year, right? So all that stuff is coming together into these models. Yeah, so I'll just ask you for a second. So you guys stare at that for a second. Tell me what pattern you see, or do you see any patterns here with our current drought monitor? Well, I don't think the population is driving it, but yeah. So in some areas of Nevada or Arizona, like Phoenix-y kind of area, yeah, it's definitely it's redder. Yeah. Yeah. In general, not maybe super surprising, the deserty, the more aridy areas are right now experiencing more drought. That doesn't mean they always experience more drought, but for right now, that's where the epicenter is. I'd also note that here's Ventura County, and we are fantastic. So and I'm not just saying this because I'm a professor here in Ventura County, but actually, this was fairly surprising to me when I started really looking into this a few years ago. We really are the poster child for the impacts of climate change in our state, or we should be one of the poster children. So we really, when other parts of the state are stressed, we're one of the first ones to go into drought, and we're one of the, not every single year, but oftentimes, and we're oftentimes one of the last ones to come out of drought. So if you have a look, it looks like Santa Barbara is droughty, San Luis Obispo kind of droughty. You start heading north, and those guys are sort of dropping out. Those guys are more into kind of non-drought conditions. And we might think that the Mojave and the desert Southwest are more likely than other places to be relatively dry. Again, this is relative to normal. So this isn't total absolute rainfall. This is how much that region gets. So this is already taking into account that, say, the Mojave already gets less rainfall than Ventura County, but it's the deviation from that expected or that long-term behavior. So we definitely seem to get our undue share of droughts right here in Ventura. And so look at, and then again, you can slice the data in different ways. In this case, this is just zooming in on our California itself. And again, when you guys go on the website and start poking around, you can pick different date ranges, and you can compare, time period 1 and time period 2, et cetera, to see how our drought compares to right before the start of the Thomas Fire, for example, or maybe right before the start of the Mountain Fire, for example. Or for that matter, right before the start of the Palisades Fire, or stuff like that. Okay, then we have other types of data products. In this case, this is where our state reservoirs are look like right now. Okay, so let me explain this one to you. Okay, so we have reservoirs oriented across the state of California. The orientation of where these graphs are is roughly where they are in the state of California. So the ones that are more north are towards the top of the display, etc. The total size of the bar, the yellow box, that's if the reservoir was at full capacity, 100% capacity, it would be total. The level of water would be to the top of that yellow bar. The green here is the historical average. I think it's over the last 20 years, I think. But I don't remember exactly, but it's some measure of historical average. And then the blue is what percentage of capacity are we. So the blue is the absolute amount, and that's telling us what we're doing. And so in this case, the Dom Pedro Dam has 76% of what would be maximum capacity. Now, I'd also just point out that given that this is a storage system, and we're not out of the rainy time of the year yet, and the snow hasn't really started melting yet in the Sierras and stuff. We need to sort of also plan for what's coming up. And so for the most part, in February, March kind of time of January, February, March kind of time of year, you pretty much don't want your reservoirs to be 100%, right? And that's to give us capacity to take on if a big storm comes in next week. We want to be able to deal with that, right? We don't want the water to go outside of the reservoir unless we tell it to. We certainly don't want it spilling over the top of the reservoir, right? That kind of stuff. So what we'll do is a lot of times we'll estimate what we think the rainfall pattern is going to be like, and we'll let some water go out so we have additional so-called storage capacity to capture whatever that rainfall in the next week, month, or whatever is going to be. So this is looking fairly good, I would say, in terms of our current reservoir status. Yeah, I'll just say that. Any patterns you guys see about this? Yes, that's the big thing. So the largest Shasta and the reservoirs that are the highest capacity are in the Sierras and in the northern part of the state. And as we get down, there's less and less storage capacity. One, because we're not bringing there's not as much surface rainfall that we're experiencing that we have to shutter into these systems. But also, some of that water from Northern California has gone to the Bay Area. And some of it's gone to the Central Valley and everything. So by the time it gets down to us, we're not shipping 100% of the volume down south. We're just closer to the end of the hose where we are down here. So definitely the largest reservoirs are north in the state of California. Okay. And then I just have, these are just some examples of getting data from these different sites. So I just wanted to show you guys. So you guys can go through all these links. Some of these links might have changed since I last checked them, in which case you can just go to you can just sort of click out one level higher and go. Sometimes they change the address, and so all the data is there. You just might have to once or twice click to a slightly different area in the website. But what I'm showing you here is the stuff we just looked at. This is the U.S. Drought Monitor. The last thing I just showed you was the current California conditions in our lakes and reservoirs. And then this is a rainfall across the Sierras. We've broken the Sierras up into 3 different managerial units based on how we utilize the water from those areas. So it's the northern unit, the San Joaquin unit, and the Tulare unit. And then we have some data here looking at snow water content. So snow is not snow is not snow, as you guys probably know if you ski. We sometimes have snow that's very almost like feathery, just very, very dusty, very light. And then we can also have like super slushy, almost like an icy type of snow where it's not very fluffy at all and it's very dense and there's a lot of water per unit volume. And so this is going to take into account both that. We have a relatively new dashboard for groundwater. Now, we haven't talked about groundwater yet. Groundwater is one of the tools that we have historically used to mitigate drought. So groundwater is water that exists subsurface. When you put a well in the ground, you're accessing groundwater. And so what we've done in the past in California, when we're in a drought, we just drill more wells, or we drill deeper wells. in the last major drought, which was the most intense we've had in recorded history in California, which was the one that was just in the late 2010s, people were really sucking down groundwater. In some cases, some parts of the Central Valley dropped a meter over the course of a year. So a lot of sucking out of groundwater. Essentially, sucking out the groundwater essentially is like if you put a straw in a glass of Coke and start sucking the Coke out, right? The level of the drink goes down. And a little bit of sucking out of the water is not going to do much, but when we take excessive amounts, that's when we start to see things like elevation drops, etc. So in the wake of that situation, we passed some new laws in California that just said, no, we have to more properly regulate and manage our groundwater resources. So because of that, we have some relatively new indicators. The newest one is this dashboard for state water groundwater conditions. And you can click around and look on this video about how you can play around with stuff. And then we have a measure of that socioeconomic dimension of the consumption side of the water and how we're doing that. And so all those are available to you. And so what I want you guys to do is to play around with all these. So we'll spend a few minutes. You guys click around, play with all these, make sure you can find them all and just, have a little bit of fun, check them out, see, make sure you can access the data and look at the patterns, etc. And then I want you guys to look at what's going on statewide and what's going on in Ventura County. And so I want you guys to, from all of these things, from all these different sources, so it's the groundwater, the snow, the rainfall, drought, blah, blah, blah. Tell me what's going on in these places. And so for each, so one for California, one for Ventura, you guys have a clear thesis as to what you think is going on in the context of water conditions here right now, as of this week. And be very specific. So don't say, oh yeah, we're doing great, or yeah, we're in drought. Why do you say that? And cite specific numbers and where you got those numbers from. So, something like this.